scientific notation. If you ever do any science later on, especially further study in science, you'll find that science deals with things that are absolutely massive, like the size of the universe, especially in physics, astrophysics, space. But also things that are really, really tiny, like tiny doses of medicine or the size of a chemical compound that you're working on to fix some disease. So in science, we need to be able to look at really big numbers and really small numbers. And scientific notation is a great way to do that. A number in scientific notation looks like something times 10 to the power of something, where this thing here is at least 1, but less than 10. Can't be 10, has to be less than 10. And this little number at the top shows whether it's a big number or a small number, because that's what scientific notation is good for, writing big numbers and small numbers. If this thing is positive, then the number is big. But if it is negative, then the number is small. It will always be times 10 to the power of something, by the way. That times 10 will always be there if it's written in scientific notation. Let's try writing these just as an ordinary number, an ordinary decimal number. When I say an ordinary decimal number, I just mean a number, a normal number, like you'd normally see. So this one is 2.5 times 10 to the power of 2. I start with the decimal point here, in between the 2 and the 5. I look at this thing here, and it's positive. It's 2, positive 2. So the number is going to be big. So the decimal point will move to make it bigger. Will it move this way? No, that will make it smaller. The decimal point will move this way, and it will move 2 places. 1, 2. So the decimal point is now here. To fill in this extra gap, you might notice that I just skipped a space. Just put a 0 there to fill that space. 2.5 times 10 to the power of 2 is 250. So this makes sense in your head. 10 squared is 100. And if I have 2.5 lots of 100, I have 250. Okay, so that number, that scientific notation represents that number. Let's try another one. Oopsie, jumping ahead a little bit. 7.1 times 10 to the power of minus 3. Well, I'll write the number. The decimal point is here, and I'm going to move the decimal point. This power is negative. So because this power is negative, this number is actually really, really small. So if I move the decimal point this way, it'll make it big. I don't want that. I'm going to move the decimal point this way because I know that it is a small number. And I'm going to move it 1, 2, 3. The decimal point will be here. These spaces I'll fill in with zeros. So the decimal point is here. Good, it's moved 3 places and it's moved to the left because the number is small. Normally mathematicians don't like to leave a random dot there because someone might miss it. So normally we would put a 0 at the start. 0.0071. You see the decimal point was here and moved 1, 2, 3 places to the left. See? Negative 3. 3 places to the left. One last one that we'll look at for converting from scientific notation is this giant number, 9.0 times 10 to the power of 20. Now I can tell you, this number, the decimal point is going to move 20 places. The power is positive, so the number is really, really big. So the decimal point actually moves 20 places to end up all the way over here. And you might think, Mr. Neri, that's so silly. This number is ridiculous. There's no reason to have this number. But if this is in meters, because that was in meters, this is the size of our galaxy. If you have to research about galaxies and space and talk about this kind of thing, how much easier is it in your paper to refer to that number all the time rather than this one? So much shorter. Anyway, next time I'll see you on converting to scientific notation. If you want to practice just this skill, then it's 2C.1 that you'll try, and questions 1, 5, 6, and 8. A weird combo, I know, but the other ones go the other way. All right, until next time.